question 31 is have to do with induction, because we know that if we got a coil of wire rotate in a uniform magnetic field, then we can have a current being induced, right, from a epsilon, and epsilon here will stand for a EMF, electromotive force. So let's just have a look at on the formula from the data booklet for the D4 for the induction. Again, there you will see that we can only have a electromotive force being induced when we have a change of the flux over time, right? And it's also have to against that change in the flux. That's why we have a minus here. So if you have a look at the flux itself, the definitions of the flux, it will equals to B A N cosine theta. So B is the magnetic field strength of the field. A is like if we got a coil of the wire like this, and then if we got like when it keep rotating, let's say the magnetic field strength at some point will be in this direction when it keep rotating, then we can see that the normal vector of the plane that defined by the coil of y lies the vector n like this one. So if we have these two together like this, that should be the angle theta here between the normal vector of the plane of the core of the wire and the B magnetic field. So basically we can see that when we have the coil of wire rotating, okay, you see rotating, whenever you have something like rotational motion, think of the angle theta being swept, okay, that something will be like a function of time because it will change along the time. So if we got this one changing, basically you got a cosine is a sinusoidal functions of the time. So if you just want to care about the change of it at an instantaneous, it just means that you take the derivative of this one. So that's why you will have the electromotive force turns out to be minus n. I will just have the B as the constant out, the error as a constant out as well, and now this one just become like the derivative over time of the cosine of the theta, which is a function of the times measured by the angular speed times with the t. Okay, here we got the constant angular speed, so the omega stay the same. So if you have learned about derivative from math, or we can just take the result of this one, you will have it equals to nba omega times with the sine of the theta is omega t. Okay, yeah, because in this one we have the omega as some coefficient before the variable t, so we have to have it here as well. We can discuss more about how do we got derivative, but basically that's math, it's not physics. What I'm trying to highlight here, you can see that this is the amplitude, the maximum value that the electromotive force can be identified, okay, and it actually depends on the angular speed. So that's why when you have the angular speed changing, you will have the amplitude also changing as well. So let's have a look at this one now. For this one, you can see that the coil of the wire rotate at a constant angular speed like omega, and you can see that the maximum value it can reach here, right, the amplitude, that's the extreme it can get, either 10 or minus 10. The positive and the negative value just want to show about like the change in the direction between the two terminal, right? At one time it will be positive and then the other time it will change to be negative. So that's about the alternating current, right? That's how it can change the rate and alternating current, which have the direction like keep changing for every half of the cycle. If you don't remember, we can talk more about it in another video. So basically this is the amplitude to be 10 volt, and now we can see that this one have changed. This one have changed to like 3/4, right? It have changed the angular speed here, so it should decrease, right? So that should be 10 times with this one, basically just like 75%, right? That's why it just dropped to like 7.5 volt for now. It have decreased because the angular speed has decreased to the new value. So that's about the amplitude for this one. So if you want to remember, maybe remember this equation, okay? This one. This is the amplitude of the EMF. And for the time period, the time period, you got it right, that's right, because it's like 2 pi over the omega. So now you got the angular speed had decreased, so the time period should increase, and it's also increased by the ratio 4/3. So this is the value. You got the time period right and ready, so the answer should be D. Okay, please let me know if you have any question. Thank you.